So we're going to learn about the tangent ratio. So the tangent ratio, and let's start with our definition. For any slope angle in a slope triangle, the ratio that compares delta y, which we've talked about delta y a lot, right? That's what we learned about in integrated 1, with the change in y, which I'm going to call that the opposite. Now instead of calling it delta y, we're going to call it opposite, to delta x, which now we're going to be calling adjacent, is called the tangent ratio. And this is exactly what we did at the beginning of the class. We took an angle and there was some relationship between the angle and the slope. So that's just now going to be called the tangent ratio. Okay? So, to start, we're going to draw a triangle. And the first thing to note is that it's always going to be a right triangle. You're never going to have a triangle that's not a right triangle when you're going to use tangent. And then we're going to call this angle the slope angle, but it could be the other one. Right? It could be the other slope angle. It doesn't matter which one you call the slope angle. I'm just going to call that one the slope angle. And then just like when we're finding slope, this one will be the change in y. So I'm going to write delta y, the change in y. But now, like I said, we're going to call that opposite. And again, just like finding slope, we have delta x here. But now we're going to call this adjacent. So we have opposite and adjacent. Now some students have a lot of trouble differentiating between opposite and adjacent and then the other one. So I like to use a ball to explain the difference, okay? So I'm on the field and I have the ball at my feet, okay? I want to pass it to somebody opposite of me and I'm looking this way. Where am I going to pass if I want to pass opposite? Which like show me like tell me when to stop with my fingers. Yeah. That's going to be opposite. I'm looking at them. That's going to be opposite, so I'm going to pass it that way. Okay, so that's opposite. Okay? Now if I have the ball, if I have the ball here, and I want to pass it to somebody adjacent to me, where is that going to go? Yeah, like somewhere here, right? Yeah. Right there. Okay, that's adjacent. I can pass it opposite, which is straight. Or I can pass it adjacent, which is to the side. Okay? Opposite, adjacent. So if you're pretending you're the angle, you're going to pass it opposite and you're going to pass it adjacent. Okay? That's for tangent. But if we look here at the slope angle, it kind of looks like we have two adjacents, right? Because that one's right next to it too. But that one's called something special. It's the hypotenuse, right? Because it's across from the right angle. So that one's never adjacent because it's always the hypotenuse. So let's write that down. Okay. If it's hard for you to figure out which one's adjacent, always label your hypotenuse. just draw that, figure it out, figure out which one's the hypotenuse, and label that, because then you know that one's not going to be adjacent. Okay? So, let's write the tangent ratio. It is written tan. I write my t's like that. That's just the math way to write t's. You don't have to write your t like that. It's not a special t. Okay, it's just t. Tangent of the slope angle equals delta y over delta x, which is exactly what slope is, and that equals opposite over adjacent. Okay? Because now we're not going to write delta y, delta x. I'm going to rewrite that without the delta y, delta x. So our tangent ratio is just the tangent of the slope angle. Oops. Tangent of the slope angle, that line shouldn't be there, equals opposite over adjacent. Okay? So tangent of the slope angle equals opposite over adjacent. And that's how we're always going to write our tangent ratios. So let's do an example of just writing the tangent ratio. Okay, so I have this triangle right here, and this little circle with a line through it. It's the Greek letter theta, and that's just kind of the universal way to write an angle. In this class, we'll write theta a lot. It's just representing an angle. That's all it means. Because theta means angle in math, so that's what we use. Okay, so now we're going to write our tangent ratio. Instead of writing slope angle now, we're going to write theta. So we write tangent of theta equals, now I'm theta, and I want to pass the ball opposite. Which letter is opposite of theta? P. P is opposite theta, because I can pass it straight to theta. I can pass it straight to P. And then over adjacent, which is Q. And that's going to be your tangent ratio for that problem. Okay, that's just how to set it up. Tangent of theta equals P over Q. Why isn't it R? R is the hypotenuse because it's across from that right angle. Okay? All right, I want you to try this one. Write your tangent ratio. So we'll have tangent of theta equals, what's opposite theta?
Is it x over y?
X over y. Because x is opposite, y is adjacent, and z is that hypotenuse. So it can't be z. Okay. Questions about just setting up that ratio? Because if you can set it up, you'll get the answers right. But I need to know if you have questions. Okay. So now we're going to learn how to use the button on the calculator. So down here I'm going to write button so that you know where the notes are, where I taught you how to use that button. Okay. And we're just going to start with an example. Okay, so we have this triangle. You always start by writing out your tangent ratio. So instead of writing theta now, what's my angle? 38. So I'm going to write tangent of 38 equals, I'm 38. I want to pass it opposite. Opposite's going to be x, and adjacent's going to be 8. So x over 8. Okay? If you can set that up, you'll get the answer right every time. You just have to set it up right. Okay? So now we're going to solve this. I teach it one way, other teachers teach it other ways. It's just whatever, how I was taught. So I may teach it one way and Mission Sato may do it another way in the videos. It really doesn't matter how you do things. It's just whatever your preference is, okay? So I'm going to put this over 1, and I'm going to cross multiply. So that means I'm going to do 8 times tangent of 38 equals 1 times x, which is just x. So now we have 8 times tangent of 38. So this is where we learned how to use the calculator. So let's all look at our calculators. Okay. Now I want you to raise your hand and look right here and tell me if it says degree. If yours says degree, raise your hand. Okay. If yours says radian, raise your hand. Okay. So if yours says radian, you would get every answer wrong, and that's why I need to teach you how to switch it. Okay. No matter if your screen says degree, you still need to watch because I guarantee there's going to be a time that yours says radian. Okay. So when you turn on your calculator, you always need to look up here and see if it says radian or degree. Okay. If it says radian, you go like this. You press mode, and then you go down to where it says radian degree. Go right and press enter on degree. Okay. It just has to say degree. When you press clear, you'll notice that mine now says degree instead of radian. Okay. It has to say degree. If it says radian, you're going to do the answer wrong. All right. Now we're going to plug this right into our calculator exactly as it's written. X times tan, which is right here. Tangent of 38. Close your parenthesis. And press enter, and you should have gotten 6.25. So x equals 6.25. Did anyone not get 6.25 on their calculator? Okay, good. Now I'm going to give you 2 more examples that I want you to try before I go over them.
Could you have put x equals 6.25?
It's the exact same thing.
Oh.
Okay. That's a 43. Yes. Okay, so go ahead and try those. Always start with setting up your tangent ratio.
Is that
73. Yeah. Start with that tangent ratio and see if you can figure out how to use that calculator.
Can you cross the fraction?
max number, then it's higher than 5, then you're gonna round up. You see what I mean?
But it's less than 60.
So I'm going to set this tangent ratio up. That'll be the tangent of 43 equals x over 11 because x is opposite. Put that over 1 and cross multiply. 11 times the tangent of 43 equals x. And you plug that right in your calculator and you're going to get x equals 10.26. Did anyone not get 10.26? So you rounded wrong. So you look at the next number, and if it's higher than 5, you round up. Okay?
Wait, that one, would it be 9 or
The next one's a little bit different, so try your best on it. See if you can figure out what to do. So this one will be tangent of 73 equals, what's opposite of 73? 9 over x, which is obviously different because now my variable's in the denominator. So when that's the case, we still cross multiply, but now we're going to get x times the tangent of 73 equals 9.
Or is that right?
But now how do I get x by itself? Divide it, yeah. You're going to divide by the tangent of 73. Divide by the tangent of 73. So that means x equals 9 divided by the tangent of 73. And you put that right in your calculator exactly as it's written. Okay, practice putting that in your calculator.